All right, so slope. I'm behind on the recording here, but we'll be all right. Again, delta y over delta x, which is change in y over change in x. So please keep in mind that y is on top. That's going to be hugely important, even maybe more important than it has been in the past. There is a formula that a lot of you have become accustomed to. Basically, just subtract the y value, subtract the x. Make sure you do it in the same order from one point to the next, and you can find the slope rather easily. For example, if we were to do the points I gave you here, negative 4, 5, and 4, negative 6, a lot of you have been accustomed to kind of labeling x1, y1, x2, y2, and using the formula. And there's nothing wrong with that. That'll work. So if we follow the formula, y2 is negative 6, minus whatever y1 is, which is 5, so no big deal there. So there's your change in y. Quite a bit, actually. And your change in x, you would take x2, which is 4, and subtract. Now here's where you got to be careful. Really, the subtract comes from the formula. Right here we have a negative 4. Okay, so be very, very careful there. Exactly, you can go ahead and do the add there. And so basically, negative 11 over 8. Is that the best slope in the world? No, not really. And I'll be honest, some of the slopes we're going to be dealing with this year are going to be fairly extreme. That's okay, but then a lot of them are also going to be a very nice number, 0. Okay, those are going to be some of the more important ones as we go along. And I know that some of you like to kind of look at things this way, because really all you're doing is you're figuring out, if I had to get from one point to the next, you could do it like that. I just went, that's 11, this is 8. Well, how come those are both positive? Well, you got to think, I really went down 11 if I went in this direction, down and over. So it'd be negative 11 and then positive 8. So do we come up with the same answer? We do. It's no big deal. Okay. So the slope there is negative 11 over 8. The reason we have to talk about it is we're going to stop talking it and calling it slope and start calling it rate of change. Okay. And so it's how things are changing, and that's where it's going to get a little bit more complicated. But we're lucky enough that some people have found some really neat tricks to make calculus a lot easier than it needs, well, could have been, I guess you could say. Okay. You may notice the point slope equation that your particular textbook likes to use is slightly different from the one you're accustomed to. You've seen this formula before in a slightly different form. It is equivalent to this one. You can use either one. It really doesn't matter to me. And what's the form you're used to seeing? No, that's slope-intercept. Close, though. I called it the point slope. Well, kind of what they did, point slope formula is sometimes what I called it. You're used to seeing it like what'd they do to it? Yeah, all they did was move the y1. They just added it to both sides just to get y by itself. So some students in the past have just said, you know what, I kind of like this newer method because it just gets me right to the equation. I don't have to do anything afterwards. But some people are used to having the y's together, having the x together. I don't care which one you use, just get it to that form. Because a lot of time you're just going to be asked to get an equation. They're not going to tell you what form. So just get it to an equation and leave it. Okay. And then sometimes they will tell you slope-intercept form or things like that. So for example, if I were to give you example 2, I will accept a variety of answers depending on which point slope equation you want to use. But again, why do they call it the point slope equation? Because you need a point and the slope. That's, you know, they're not tricky with how they named it. That's what you need. Okay, and so the first thing we'd have to do, well, we have 2 points. Right? So we can pick which one we want to use. That's kind of nice, but we don't have the slope. So if we're going to do change in y, all right, so x1, y1, x2, y2, we would do negative 3 minus 1, because again, change in y is on top. And 8 minus 2, very good. And so negative 4 over 6. Yep, as you say, negative 2/3. Very good. So is negative 2/3 the answer to the question? Yeah, that is your slope. So do you want to use the point slope equation that I wrote in black up above, or you want to use the books? Again, I don't really care. Use the book one? Okay. So basically the book one says, all right, you just write y equals, and then you write down the slope. All right, negative 2/3. X minus, because there's no subscript on this x right here, so you just leave it, minus x sub 1. Well, x sub 1 depends on what point we want to use. I got a pretty good idea which one I would probably use. Yeah, 2, 1. Why would you use that one? The numbers are smaller. Why wouldn't you? All right, so x minus 2, and then according to that, it's plus whatever y1 is, which is 1. Because you have to pick the x and y from the same point. You can't just pick x1 from one of them and y1 from the other one. Okay, that's an acceptable answer. Is it okay then, based on what I told you, to write that? Yeah, that's fine. That's the method that you've learned throughout algebra 2, geometry, algebra 2, advanced math. That's kind of the form that you've learned. And that's what it says. Find the point slope equation. We've done that. Okay. Any questions? Okay. Just for your reference, the only reason I prefer this one is because if I divide both sides by this, it's my slope equation. Okay, and that's the only reason. And basically, they came up with the point slope equation just by multiplying that over, and they said, here you go. Okay, and so that's the only reason that I prefer that one. Any questions so far? All right, moving right along then. The y-intercept. Or intercepts is or are, I probably should have in there. The places or place where the equation does what? Or the graph, I should say, of the equation. Yeah, hits the y-axis. Or sometimes I like to say, or in other words, if you're hitting the y-axis, what can you tell me? If you got a graph and you know you're hitting on here somewhere, what's one thing? Every single point on there has one thing in common. What's 0? Not necessarily. X is 0. X for those points is going to equal 0. It has to. If you're on this y-axis here, the x value has to be 0. And in the same kind of idea, x-intercepts are then where it hits the x-axis. And if we're trying to hit this x-axis down here, yeah, y's got to equal 0. Just the y value has to equal 0, all right? I think we can agree that the equation y equals 0 would actually be the x-axis, and x equals 0 would actually be the y-axis, but that's not what we're talking about here. Okay. Here's what some of you talked about earlier, slope-intercept equation, y equals mx plus b. This one will be important, but maybe not as important as it has been in the past. You may be asked to get that from time to time. And so if we're going for slope-intercept equation, there's one thing I want you to be able to do. Actually, you need to be able to do slope, but I want you to realize where you have to go to get started. And where you need to go to get started, no matter what form I ask for it in, is right there. This is a formula. This will get you to any form you need, but you got to use it. Okay? So again, apparently you like the book one, the one that kind of gets y by itself. Is that what I'm understanding here? So we can use that. I don't have a problem with that. So the equation, again, this is what they want it to look like when you're done, but it's not that easy to jump right to that. There's lots of ways of doing it, but this is a pretty simple one. Right there. Right. Well, the first thing we got to do is slope. I think we're getting pretty good at that. So it'll be 4 minus a negative 1 over 3 minus a negative 2. Very nicely. 1. Okay. So if I get going too fast, let me know. Y equals, well, there's an m, so put 1. X minus, well, now we have to make a choice. Depends on which of the two values you want to use. You want to use these right here? We're going to make that choice. Is that what you want to do? Choose negative 2, negative 1 as our point. Again, remember, point slope equation, not points. You just got to pick one. So x minus negative 2. All right. Now what do you do? I'm glad you chose that one because it says plus y1 now. Yeah, but it's plus a negative, right? So it's really just minus. So that's really no big. But I wanted to make sure. You know. So y equals. Well, what can I do with that 1 now if I really felt like it? Okay, should we do that or should we just leave it? Why? Because they want it to look like that. Y equals mx plus b. Does that have parentheses in it? No, we better keep going. So we distribute, and okay, so it's x plus 2 minus 1. So is that slope-intercept form? Oh, it's really close, though. Just take the 2 and the negative 1 and combine them, and we get the slope is 1, and the y-intercept is, how'd you know that? Ah, yes, b is the y-intercept, don't forget. So if it's ever in this form, you can find the slope, which is right there, really easily, and the y-intercept very easily. And the y-intercept, don't forget, is where it would hit the y-axis. Yep. So you can always write the 1 in there if you want. There's nothing wrong with that. How we doing? Good? All right. Well, this one can be done quickly if we remember the little shortcuts. But if you don't remember the shortcuts, here's again, I want you to know the process of getting to the shortcuts so you can use them again. Instead of having to memorize everything. If you're really good at that, well, good for you. But again, the process is going to help you out a whole lot. So that's general form, sometimes called, what else was it? Standard form. It depends on the textbook that you have. I want you to determine the slope and the y-intercept. You agree that was pretty simple back here, wasn't it? Well, I was just sitting right there, wasn't it? Well, here it's not. But you can get to it relatively quickly. Does anybody remember the shortcut for slope? Whoops, or y-intercept when it's in this form. And it's okay if you don't. But again, I want you to be able to get to the process. Morgan? Close. Opposite of A over B is what it is. Now again, let me show you, once we do this, let me show you where that comes from so that if you get to college and your professor doesn't give you that shortcut, you can figure it out. All you have to do to remember these shortcuts is take this and put it in slope-intercept form. Get y by itself. All right? So to get y by itself in this, what's probably the first thing you're going to do? Well, here's y. We got to get ax out of here. And what are you going to do then? No, just in this general. Yeah, just subtract it out of there, right? So what you're going to do is you're going to have by equals negative ax plus c. You agree you're going to move it to that side, get x where it's supposed to be in this form. And what are you going to do? Divide by, you got to get y by itself, so divide by. Are your shortcuts just sitting right there now for you? Slope is negative a over b. Y-intercept is c over b. It's sitting right there. Again, process. Let's try and stay away from the memorization if we can. With that in mind, does that make this problem a whole lot quicker? Yeah. Is there a question? Oh, I was going to write an equal sign. You mean here? I was going to write an equal sign, and then I realized I had to do y-intercept yet, so I just tried to change it into a hyphen. Yeah. Got a little ahead of myself there. So the opposite of a over b. Well, what's a in our problem that we have here? A is 2, b is 5, c is 7. Okay, so it'd be the opposite of a over b, which is 5. And the y-intercept is c over b, which is 7 over 5. And the reason those two things are so nice is it's so easy to graph them when you get those two things. You just do the y-intercept and you do your slope, remember, which is change in y over change in x. So this would be down 2 over 5, or to the right 5. It's so much quicker to graph them. I don't know why there's another slide. We'll just check it out. That's fine.